All right, so as your math teacher today is citing for me, we are talking about slope-intercept form, which I absolutely adore working with. Slope-intercept form is arguably, in my mind, the easiest way to come up with the equation for a line. So I know finding those equations has been difficult for you guys. Slope-intercept form makes it really, really easy to find that equation. So there are a few vocab words here, 5 it looks like. If you would pause your video, do your heading, we are going to go through part 1 and part 2 together, but part 2 has no new vocab, so just go ahead and just do those 5 vocab words and your one heading and come on back. All right, so our first vocab word is a parent function. A parent function is the simplest form of a function. So there are different groups of functions, and the simplest form in each group is called the parent function. The linear parent function, or the simplest form for a linear function, is simply y equals x. Y equals x is the simplest function that you can have, and your line, I'm going to go right through the origin, your line is going to look like this. So that is the linear parent function of y equals x, the simplest linear function that you can have. A linear equation is any equation that models a linear function. So that's going to be a straight line with the exception of a vertical line. A vertical line, again, it's not a function. Slope is undefined. It fails miserably at the vertical line test. It is not a function, but any other straight line is in fact a linear equation. Your y-intercept, which is super important in slope-intercept form. When we talk about intercept, that's where something is crossing something. And in slope-intercept form, the y-intercept, or where that line is hitting the y-axis, is super important. So wherever your graphed line intercepts or hits the y-axis, that's called your y-intercept. So here it would be 0 because that's where it's hitting. If I draw another line here and I have my line say something like this, and this is 1, then my y-intercept would be 1 because that line is intercepting the y-axis at 1. Okay, it's super easy to figure out what your y-intercept is as long as it's a whole number. If it's in between, it makes it a little bit harder, but if it's at a whole number, super easy to look at your graph and say, okay, well, it hits at 1. Last thing here, last vocab, is the y-intercept form. The y-intercept form is y equals mx plus b. Now, m we talked about in the last section is slope. B is that y-intercept. So we are super familiar with equations that are set up like this. For example, we could say y equals 2x plus 7. In this case, our slope would be 2 and our y-intercept would be 7. Using those two facts, we can actually graph our equation already. It's that simple. We go to 7 on our y-axis. If our slope is 2, we think of that as 2 over 1. So we would go up 2 to the right 1. So we would, again, go to 7 on our y-axis. And here my axis to be a little bit longer. So I can then go up 2 and I would go over 1. So from your y-intercept, which is 7, we would go up 2 over 1. And we could do that again, up 2 over 1. As soon as you have 3 dots, you can make your line and you're good to go. Fantastic. I absolutely adore slope-intercept form. All right, so next up we are identifying the slopes and the y-intercepts in some equations. I'm going to leave up our equation here in slope-intercept form, y equals mx plus b, to help us out. The first problem that they give us is y equals 5x minus 2. So this one already has something to pay attention to. So looking at this, we can tell our coefficient to x is 5. It tells us that the slope is 5. Now looking at your y-intercept, you see 2, right? So we can say 2, but here's the issue. Our formula is plus. So our formula says y equals mx plus b. Notice this is subtraction, not a plus. Because of that, you need to change it to plus negative 2, and then we can say that our y-intercept is negative 2. Okay, there's no more switching around. You just have to change that subtraction sign to an addition sign, make your number negative, and then you're golden, and we can say that our slope is 5 and our y-intercept is negative 2. Try out at 1a and come on back. This equation is y equals negative 1/2 x plus 2/3. So here we would say our slope is negative 1/2 and our y-intercept is 2/3. It's always going to be whatever your coefficient of your x, that's your slope. The number that's by itself, so the constant, is going to be your y-intercept. Moving on to example 2, here they're going to give us the slope and the y-intercept. We come up with the equation. So in problem 2, they're saying that the slope is negative 4/5 and the y-intercept is 7. So we can plug those into this formula and say that y equals negative 4/5 x plus 7. Remember that that formula is plus. This is a positive, so we say plus 7. Got it too? If you want to pause your video, try it, and then come back. We have, what's it tell us? Slope is 3/2, and our y-intercept is negative 1. So it would be y equals 3/2 x minus 1. You could put plus a negative 1, that's equally correct. Just a little more simplified to go ahead and say minus 1 rather than plus negative 1. Both are correct though. Next up, we have writing equations from a graph. So this, you're going to have to read the graph, figure out what the y-intercept is, figure out what the slope is like we did in 4-1 or 5-1, and then you can write your equation. When you look at problem 3, we're looking for those red dots where our graphed line hits an intersection between the horizontal and the vertical lines. Once you find that, you're going to count up or down and then count to the right. So in our example here, we go up 1, 2, 3, 4, 5, 6, and over 1, 2, 3. So 6 over 2 would reduce to 2. So our slope is 2. Our y-intercept is just wherever that line hits the y-axis, which is your vertical line. So if we look, our y-intercept here is negative 2. Once we know that, we can go ahead and plug into our slope-intercept form and say that y equals 2x minus 2. That would be our equation here. Try got it 3, pause, come back. If you look at got it 3, we're going to check out our graph. I'm going to start with 0, 2, and then I can see that it goes down 1 to the right 1. So my slope would be -1. And my y-intercept here, wherever my line hits the y-axis, is +2. So our got it 3a would be y equals -1x plus 2. I can simplify this and just say -x plus 2. Y equals -x plus 2 would be a nice simplified answer. Moving on to problem 4, we are given 2 points. In that case, there's a couple things that we need to do. The first is we need to find our slope. So our 2 points are 2, 1, 5, -8. I have decided these are going to be my 2s, these are my 1s. So I am going to plug these on into the slope form. And let's see, y2 would be -8 minus y1, x2 minus x1. So I would get -9/3, which just reduces to -3. So my slope here is -3. Once I know that, I can plug that into my y equals mx plus b. I don't know b yet, but what I do know is 2 different points. So I can pick either point and then plug it in for x and y, and then I can solve it out for b. So then I'll know b. I'm going to choose to use this order pair because these numbers are more simple than these. I'm going to put 2 in for my x, 1 in for my y. Make sure you're putting the first number in for x, the second for y. And then if you do a little bit of math here, solving an one-step equation, oops, and we get 7 is b. So now we know that m equals -3, 7 equals b, and we can plug into our slope-intercept form and say y equals -3x plus 7. So that is how you go from just 2 distinct points, you find the slope, you find the intercept, and then you have your slope-intercept form. Here I got it 4, and then come on back. Got it 4 again. We are given 2 points, so we're given 3, -2, and 1, -3. We're going to first find our slope. It's kind of 6 of one and half a dozen of the other, as my mother would say. Which one should be my x's, or which one should be my 1s, and which ones should be my 2s. I'm going to make these my 2s, these are my 1s, and substitute in then. Remember that in this formula it's minus, so here I have a minus and negative. And then here I would have 3 minus 1. So these double negative, that would equal 1. and this equals 2. So my slope here is 1/2. Now I can use one of my order pairs, and again, don't really have a preference which one I'm going to use. I don't know, I guess I'll use this one. So -3 equals 1/2. Oops, we know x is 1 here. Since I used -3 for y, my x is 1 plus b. And then I'm going to multiply, subtract 1/2 from each side, and I'll get b. So -3 minus another half would be -3.5, which if I make that improper, be -7/2. Then I can plug both of my slope and my y-intercept into our formula, and I get y equals 1/2 x minus 7/2. Sure, you guys can see that. So y equals 1/2 x minus 7/2. That is our answer for got it 4. We are going to move on to part B here, just because part B doesn't add a whole lot more. So in part B, they have given us an equation and we need to graph. So the cool thing about these is, and I'm on page 334 now with problem 5. The cool thing is, if our equation is in slope-intercept form, we can look at this and pull out our slope and our y-intercept. Just remember that y-intercept form, I'm sorry, slope-intercept form has a plus here. Okay, so this is a minus, which means our y-intercept is going to be -1, not +1. Okay, you're going to think of that as plus, minus, plus a negative, I mean. So our y-intercept is actually -1. Our slope here is 2. Knowing those two things, we can graph. So we're going to make a little graph. Our y-intercept is -1. Draw some grids, and these just need to be sketches of graphs. So our y-intercept is -1. That means one of our points is going to be here. Our slope is 2. So we're going up 2 over 1. Up 2 over 1. As soon as you get 3 points, you can go ahead, if you want to use a ruler, you can, and make your line. There you go. It's as easy as that. Try got it 5A and 5B. Sketch of a graph like this. First pull out your slope and your y-intercept from your function, and then sketch a little graph. For got it 5A, we have y equals -3x plus 4, and b, we have y equals 4x minus 8. So our slope over here is -3. Our y-intercept is 4. If we think about that graph, we know our y-intercept is 4. That's where our line is hitting that y-axis. -3 means our slope is going to go down. Our line is going to go downhill. So we are going to go down 3 to the right 1. Remember, you're going to the right. Negative means we're going down 3, and then it would be 3 over 1, so we're going to the right 1. And then again, we would go down 3, 1, 2, 3, to the right 1, and that is enough to make our lovely line. Over here, our slope is 4. Our y-intercept is -8. So we are going to need a bit of a line here because we need to go down to -8. 8. So that would be 1 point, and then our slope is a +4. So we're going up 4 to the right, 1, 2, 3, 4, and then to the right 1, up 4, to the right 1, and there's my line. Okay. So that is graphing from slope-intercept form. Super easy to pull out those numbers. Pick your slope, pick your y-intercept. Go to your y-intercept first, and then use your slope to figure out where to put the next 2 dots, and then connect them, and you have your line. Problem 6 is a word problem that really relates well to these. So it's talking about water pressure, which can be measured in ATMs, and let's see, use the information in the diagram to write an equation. So it shows you in this picture that at 0 meters, the pressure is 1 ATM. Pressure increases 1/10 of an ATM per meter. So they have actually graphed it for you. So they came up with some X's and some Y's for you. The rate of change here is 1/10, and it told you that in the problem, that 1/10 of an ATM per meter is the rate of change, and that is a y-intercept of 1, which it also told you that at 0 meters the pressure is 1. So it told us that to begin with, and that's it. They've graphed it for you. You're good to go. The got it here is about a plumber who charges $65 for a repair plus $35 an hour. So to walk in the door would be $65. That's your y-intercept. They haven't done any work yet. You're still at 0 hours, but you've already paid $65 for them to walk through your door, and then you pay $35 an hour. So you would go up from 65, you go up $35 every hour, and you'd be able to graph that line pretty easily. What I want you guys to do now, just give me a second. Here are the problems that I would like you to do on page 332, 9 to 30 by 3s. Page 336, I want you to just try 5 and 6. 10 problems. Do those and then come back for the lesson check after you have submitted your work. See you guys soon.